Let's now take a closer look at the processes that occur when we are running a transaction object. Let's use the attraction transaction as an example. On one hand, at the front-end level, from the web layout, we will have the screen in the web browser with which the user will interact. And on the other hand, at the database level, that is, the backend, we will have the table associated with the transaction, and those of its extended table that must be accessed to perform integrity checks and infer data. From the front end then, processes will be triggered in the backend to, among other things, perform data checks and of course create, update or delete. If we look more closely, there will be transaction code that runs on the client in the browser and code that runs on the application's web server, which is the one that has access to the database. The client code is, for example, both the one that renders the UI user interface of the screen and the one that controls everything the user does and sees, the one that provides immediate feedback for each action. Let's review this with an execution example. Suppose we enter the transaction in insert mode. Since the ID is auto-numbered, it will place us on the first editable field of the screen, in this case attraction name, and will validate that the value entered by the user matches its data type. At first, this does not require running program code on the server. It can be handled directly on the client. The case of the next field, of type image, is also solved entirely on the client side. On the other hand, when the field is a reference to another table, as in the case of category id, in addition to only allowing a numeric value to be entered, referential integrity checks will be triggered from the client, for which it will be necessary to run code on the server. So, it is the transaction code shown here that makes a call to the database, looking for a record in the category table with, in this case, primary key value 8. If it doesn't exist, the database software will return a not found code to the program on the server, which will be returned to the client, so that the screen displays the no matching message that the user sees instantly. If the user now changes the category id from 8 to 1, the validation on the server is triggered again, which searches the database for a record in category with ID 1. And since in this case it exists, it also returns the category name, which reaches the front end through the server, and is then displayed on the screen, providing immediate feedback to the user, who now sees the inferred category name. And what will happen with the transaction rules? For example, if there is an error rule that must be triggered if the user leaves the attraction name empty, the rule will be evaluated and triggered on the client as soon as the user leaves the attraction name field. If it was left empty, then without any need to go to the server, the rules message will be shown to the user. We could then think that in this case both the rules and the validations that do not involve querying the database are only executed on the client and never on the server. However, this is not true. When the user confirms, everything that has been running on the client will run again on the server in the same order. Let's take a closer look. On confirm, the front end sends to the back end all the data entered by the user, and the back end goes through each field one by one, triggering the validations and rules again. When this first foreign key is reached, the integrity check is performed again and the category name is retrieved and saved to be returned to the front end upon completion. And then the next foreign key is checked, this time a composite one. If found, the country name and city name values are retrieved and are also saved to be returned later to the front end. This triggering again on the server, here in batch mode, of Everything that had already been triggered there interactively on the client is because only on the server can we guarantee the security and consistency of the data. It is the server that has the ultimate control over what is stored in the database, protecting the application from potential attacks or manipulation from the client. Let's take a closer look at the process we've just followed closely, which was performed on the server in batch mode after confirm with this data. When attraction name field was being validated, since we had this rule, its condition was evaluated, and with this data, it resulted in true, so it was triggered. And this error result was registered for when the rest of the fields were finished processing. When this one was validated, the referential integrity check was successful, but if it had not been successful, the error would also have been registered for later. And the same can be said of this other check, which in this case was also successful. However, because something failed during the validation process on the server, in this case, the error rule on attraction name was triggered. The record will not be saved in the attraction table. A single failure, such as an error rule or referential integrity check, is enough to prevent the record from being saved. We can say that the insert operation on the table, which is automatically added by GNexus in the transaction program code, is blocked by a prior validation operation. This validation operation will fail if any of the field validations fail or if any error rule is triggered. In that case of failure, the result is returned to the client, which refreshes the screen with the current information. No visible changes occur since the error message was already displayed before pressing confirm. Naturally, if there had been any other errors, e.g., no matching category or no matching country and city, all the errors would have been displayed. In this case, only the error rule on attraction name failed. Now let's look at the happy path. Let's suppose the user completed the data like this on the front end when they clicked on confirm. The only difference will be that they entered a name for the attraction. At this point, all field-by-field rules and validations will have already been triggered interactively on the client. In particular, one of the rules that will have already been evaluated is the error rule at the attraction name level, which will not have been triggered, because this time, unlike the previous case, the name is not empty. Once the user clicks on confirm, as mentioned before, all the data is sent to the server. And everything will be triggered again on the server, here in batch mode, following the same order in which it was triggered on the client. Since in this case there will be no errors, not from rules, data types, or referential integrity, once the last field is processed, all the information will be considered validated. And immediately the DBMS will be asked to insert the new record in the attraction table. Since the ID is auto-numbered, a record will be inserted into attraction with the value for attraction ID corresponding to the next number according to the last one used. The insert operation on the database is performed physically. If it is successful, we will know that the new record has been created, but it will remain in a volatile state until the operation is endorsed with another database command known as commit, which makes the most recent updates to the database final and permanent. Let's consider this case. If the record was successfully inserted and before starting the commit, a failure occurred, such as a power outage, then all records that were inserted, updated, or deleted without having received the approval granted by the commit will be rolled back when the database is recovered, and therefore record 4 will have been lost. The time between the insert and the commit is minimal, but let's imagine what would happen if this commit did not exist. The inserted record would remain in a volatile state waiting for some random future commit to make it permanent. That's why after the insert request to the database, a commit request will follow, and it will only be executed if the insert was successful. So here we have these 3 operations written automatically in the transaction program on the back end. the last two operate on the database. Once the commit is completed, the successful result and the data are returned to the front end. Note that among the data sent back is the ID assigned to the attraction, as well as the values of the inferred attributes. The front end will then receive them, and if it doesn't have the pattern applied, it will display the success message and clear the form. And if instead it does have the work with, it will return to the caller, which, when executed, will display the new attraction. This concludes our explanation of how GeneXus builds, for the transaction object, the logic that will run on the client and the logic that will run on the server, accessing the database from there. We have also seen that all the rules executed on the client will be executed again on the server. Additionally, the server will execute the actions related to database manipulation.